Hello, Matthews Gatos here. Welcome to Estimating Square and Cube Roots. Let's get started. To recap with you, a perfect square is a number that has two identical factors. The square root is one of those two identical factors. So for example, if I know 3 times 3 is 9, that makes 9 a perfect square because it has two identical factors. The square root of 9 would be 3, one of those two identical factors. Now we can put perfect squares into our calculator simply by going into y1 and entering in x squared, which is just x times x. I showed you guys how to do that in another video. I just wanted to remind you of that. So when I go into the table, y1 contains all my perfect squares and x contains all the square roots. So far what we've been doing is we've been taking and calculating square roots. Here's what a calculation of a square root looks like. I take the square root of a whole number and I get a whole number answer. Therefore, I can say the root is rational and I have calculated it. For example, the square root of 9 is 3. In this video, I'm going to show you what happens when I take the square root of a whole number and I end up with a decimal number. Well, in that case, the root would be considered irrational and I must estimate the square root. For example, square root of 8. It's not one of my perfect squares, so I can't calculate it. I would have to estimate it. Let's look at that on the graphing calculator. So square root of 8 equals, and see, it's not a nice number. It's a non-ending, non-repeating decimal. So I would have to estimate that square root. So I'm going to look at how do we do that without using our calculator. I'm going to use what I know about perfect squares to estimate. So here are the first 10 perfect squares listed out, and I want to use those to estimate the square root of 27. So root 27. 27 is not a perfect square, but looking at my perfect squares, I know it's in between 25 and 36. So since 27 is in between 25 and 36, the square root of 27 will be in between the square root of 25 and 36. Now, if we look at 27, it is 2 away from 25, and it is 9 away from 36. So I can see it's definitely closer to the square root of 25. Now, the square root of 25 is 5. The square root of 36 is 6. So in between 5 and 6 are a whole bunch of numbers. The square root of 27 is going to be closer to the square root of 5, or sorry, the square root of 25, which is 5. So I'm going to pick any number between 5 and 6 that's closer to 5. So for example, I could say that 27, the square root of that, is approximately, you could say 5.1, 5.2, 5.3. Those would all be good estimates. Now I can check on the calculator to see if I'm reasonable. So square root of 27. And I can see, my estimate of 5.2 is pretty good. Okay, let's try another one. Let's try estimating the square root of 71. So 71, not a perfect number, perfect square, but it's in between 64 and 81. So since 71 is in between 64 and 81, the square root of 71 will be between the square root of 64 and 81. So you just have to look at it and see which one is it closer to. Well, 71 is closer to 64 than it is to 81. That means the square root will be closer to 8 than it is to 9. So between 8 and 9, whole bunch of numbers. The square root of 71 is falling in between 8 and 9, but closer to 8. So you just have to pick a number. Now it's not hugely closer to 8, so I'm going to say that the square root of 71 is approximately, I don't know, let's try 8.3. Okay, and we can always check on our calculator to see if that was a reasonable estimate. Okay, so square root of 71, and I get 8.4. So you see my 8.3 was in the ballpark. Okay, let's look at perfect cubes now. Perfect cubes are numbers with 3 identical factors. So a cube root is one of those 3 identical factors. So for example, if I have 3 times 3 times 3, that's 27. 27 is therefore a perfect cube. 3 identical factors. The cube root of 27 is 3, one of those 3 identical factors. You can also generate perfect cubes on your calculator going into y1 and entering in x cubed, which is just 3 of the same number, x times x times x. In the table, second graph, y1 has all the perfect cubes and x has the corresponding cube roots. So just like we did for square roots, we can do the same thing for cube roots. If I take the cube root of a whole number and the answer is a whole number, then I know it's a rational number and we have just calculated the root. So for example, the cube root of 8 I can calculate to be 2. But if the cube root of a whole number gives me a decimal number, that means the root is irrational and I have to estimate it. For example, the cube root of 9. Well, 9 is not a perfect cube. So if I went into my calculator, I would have to go in here, cube root of 9. I'm going to get a decimal answer. So I'm going to have to estimate. So again, I'm going to show you how to do that without using your calculator. So borrowing what we know about perfect cubes, let's estimate. So cube root of 100. 100 is not a perfect cube, but it is in between these two perfect cubes. It's in between 64 and 125. So since 100 is in between 64 and 125, I know the cube root of 100 will be in between the cube root of 64 and 125. Well, the cube root of 64 is 4, and the cube root of 125 is 5. Now, looking at the number, 100 is closer to 125, which means the cube root of 100 will be also closer to 5. So cube root of 100 will be a number in between 4 and 5, but closer to 5. So I just have to use an estimate. So it's closer to this, not hugely closer. It's kind of like closer to the middle, I would say. So I'm going to guesstimate that it's about, I don't know, 4.6. So as long as you're in the area and you're on the right half of the side, so you're in the top half or in the bottom half, I think that's a good estimate. So let's try cube root of 100 and see how close I was. So math, option number 3, cube root of 100. Oh, let me try that again. So math, option number 4, sorry, cube root of 100, and I get 4.6. Oh, so that was a pretty good estimate. Okay, but anything 4.6, 4.7, 4.8, 4.9 would be okay because you're in the top half. Let's try one more example, cube root of 450. So 450, not a perfect cube, but it's in between these perfect cubes. So since 450 is in between 343 and 512, I know the cube root of 450 is in between the cube root of 343 and the cube root of 512. So looking at this, I just want to see which one am I closer to. So is 450 closer to 343 or is 450 closer to 512? Well, it's definitely closer to 512. So that means that the cube root will be in between 7 and 8, but closer to 8. So I just have to pick any number on the top half between 7 and 8, so 7.6, 7, 8, 9, etc. And that would be a good estimate. So I'm going to say that the cube root of 450 is approximately, I don't know, I'm going to go 7.6. So let's go ahead and check that out to see if we're good on that. So math, option 4, cube root of, I already forgot my number, 450. Cube root of 450 is equal to 7.7. So my estimate of 7.6 was pretty close. Okay, so that's how you estimate square roots and cube roots. And doing this reminds me of what my favorite drink is. Anyone guess what my favorite drink is? Aside from coffee, of course. Here is my favorite drink. Now, that's not beer, but in fact, root beer. And my favorite would be A and W. So if you liked this video, please give it a thumbs up and hit subscribe. It helps me reach more mathies in need of help. Thanks for watching, and see you for the next one.